Assalamu alaikum everyone, this is Hamza Noor, and today here I am with the question from A level math 9709, May June 2019, paper 31, question number 5, pure mathematics 3, and this is the topic differential equations. And first part is saying that differentiate 1 upon sine square theta with respect to theta. As we know that 1 upon sine square theta can also be written as cosec square theta, but here we will differentiate it using the quotient rule. So u is equals to 1, u dash is supposed to be equals to 0. V is equals to sine square theta, which actually means sine theta the whole squared. This is exactly the same thing. And we can, just differentiate it using the simple process of chain rule. So V dash is supposed to be, this 2 will be multiplied over here as a constant. Sine theta raised to the power 1 means sine theta as it is. And then multiply by the derivative of sine theta, which is supposed to be cos theta. So according to the sequence of quotient rule, Vu dash minus Uv dash and then divided by V square. Okay. So Vu dash minus Uv dash and then divided by V square. So Vu dash is sine square theta times 0 minus 2 sine theta times cos theta and then divided by V square, meaning sine square theta is squared, which becomes sine raised to the power 4 theta. Okay. So this is minus 2 sine theta over cos theta. Minus 2 sine theta multiplied by cos theta divided by sine theta raised to the power 4. Okay. So this sine theta and 1 sine theta gets cancelled out. Therefore, you are left with minus 2 cos theta divided by sine cube theta. This answer is completely acceptable. No issue in this. You will get your 2 marks over here. But the thing is that this result will be used in the second part. And for that purpose we have to arrange something over here. All right, so we will see in the second part. The variables x and theta satisfy the differential equation x tan theta times dx over d theta plus cosec square theta is equal to 0 for theta is between 0 and pi over 2 and x is greater than 0. It is given that x is equals to 4 when theta is equals to pi over 6. Solve the differential equation obtaining an expression for x in terms of theta. First of all, we can rewrite this whole equation like this: x tan theta multiplied by dx over d theta is equals to minus cosec square theta. Okay, and then we have to separate the variables. We have to take all of the terms of theta with d theta, all of the terms of x with dx. So x multiplied by dx and minus cosec square theta is on the right hand side of the equation. D theta will be multiplied over here and tan theta will be divided over here. All right. So what we are doing, we are integrating x with respect to x and integrating minus cosec square theta over tan theta with respect to theta. Now, what I can do over here is, since I can break this whole thing like this, 1 upon tan theta multiplied by minus cosec square theta. Okay. So this can be rewritten like this. Since 1 upon tan theta is actually cot theta, so what we will do, we are integrating x with respect to x on the left hand side, and on the right hand side we are integrating minus cot theta times cosec square theta with respect to theta. It makes sense, isn't it? Now the thing is that in such type of questions, obviously you have to you have to use the result of the previous part. In the previous part, what we saw that minus 2 cos theta divided by sine cube theta. Now, what we can express, what we can, write something else over here so that we use the integration as a reverse process of differentiation. Okay, so let me make it quite easier for you. When we differentiated 1 upon sine square theta, when we differentiated 1 upon sine square theta, what we got? We got this thing, minus 2 cos theta divided by sine cube theta, isn't it? Minus 2 cos theta divided by sine cube theta. So this means that when we differentiate it, since 1 upon sine square theta can be written as cosec square theta, when we differentiated cosec square theta, we got this thing minus 2 cos theta divided by sine theta and then multiply by 1 upon sine square theta. Okay, so this definitely means when we differentiated cosec square theta, when we differentiated cosec square theta, our result is minus 2 cot theta. Since cos theta over sine theta can be expressed as cos theta, and 1 upon sine square theta can be expressed as cosec square theta. We got this thing in the earlier part. And since we are integrating this thing now, minus cot theta times cosec square theta, and since we know that integration is the reverse process of differentiation, we will be using the result of part 1 over here. So since integration is a reverse process of differentiation, so if we integrate minus 2 times cot theta times cosec square theta with respect to theta, what you will get is exactly cosec square theta. As simple as that. And obviously a constant term plus c. But what we want is the integration of minus cot theta times cosec square theta. We don't need this 2. We don't need this 2, right? For that purpose, we will divide 2 over here, meaning we will multiply it with 1 over 2 in order to cancel out 2. So definitely we will multiply 1 over 2 over here as well. This proves that the integration of minus cot theta times cosec square theta with respect to theta is exactly equals to half cosec square theta plus c. Makes sense? So now we can use, now we know how to use the result over here. So when we integrate x with respect to x, we will get x square over 2, and then the integration of minus cot theta times cosec square theta is half cosec square theta and then plus c. Okay, so you will add c on the right hand side of the equation. So x square over 2 is equals to 1 over 2 times cosec square theta plus c. But the requirement is not complete over here. You need to express x in terms of theta, and you have to put the initial conditions as well in order to find the value of constant term c. Let's have a look at that thing as well. The question is saying that when x is equals to 4, theta is equals to pi over 6. When x is equals to 4, theta is equals to pi over 6. Okay, let's just put it. 4 square over 2 is equals to half times. Now, since you know that you can't put cosec square theta directly in your calculator, what you can do is use the reciprocal function, the reciprocal identity. Cosec square theta can be expressed as 1 over sine square theta. So this will be written as 1 over sine square theta, and we need to put theta is equals to pi over 6 over here. So sine pi over 6 is squared, and then you have plus c. So 4 square over 2, 16 over 2 is 8. 8 is equals to half into, just put this whole thing in your calculator, 1 divided by sine pi over 6 squared. This gives you 4. So 8 is equals to 2 plus c, so the value of the constant is 6. C is equals to 6. Now your equation is something like this. X square over 2 is equals to half cosec square theta plus 6. But the requirement is not yet complete now. We have to obtain an expression for x in terms of theta. We need to make x the subject. So this is a result so far. So x square will be equals to 2 is multiplied with 1 over 2 times cosec square theta plus 6. So x square is equals to cosec square theta plus 12, and x will be equals to, I'll take under root on both sides, x will be equals to plus minus under root of cosec square theta plus 12. But since we know that x is greater than 0, so only positive under root will be considered. X is equals to under root of cosec square theta plus 12. This is supposed to be your final answer. Alright, so I hope this helps. Thank you for watching.